brief summary of constructing a basic exponential function. That's the y equals 2 to the x function. We make the table, we list all the standard values from -2 to 2. We plug them in when it's possible. We cannot calculate 2 to the -1/2 exactly, or 2 to the 1/2 exactly. You'd be hard pressed to calculate even a good approximation to 2 to the -1/2 or 2 to the 1/2, except using a calculator, which is at this point of the course forbidden. Okay, so the domain of the basic function, which just consists of the points here, 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 and here, and they've been a little bit obscured in the preceding video, of which this is a summary. There you can see them. Those are the points. The domain consists of all the x values, and of course you could read them from the table as well, or from the graph. The range consists of all the y values. We can do the extended basic exponential function, which is this purple curve. Okay, the basic exponential function, just these 5 points. But we can do a nice smooth curve through those points and approximate the extended basic exponential function. There it is. It's got a domain from -2 to 2 because the x values in this curve go from -2 to 2. Range from 1/4 to 4 because the y values in the purple curve go from 1/4 here to 4 here. We do the complete exponential function. We continue in the negative direction. We notice that every point, if we move 1 unit to the left at a time, at every point, every time we move 1 unit to the left, our values get half as great. And it should be obvious why that is if you understand negative exponents. So that we continue. Every time we move 1 unit, we get twice as close to the x-axis, meaning it doesn't take long to get really, really close to the x-axis so that the axis appears to merge with the curve. That gives us what we call a horizontal asymptote. It's asymptotic to the x-axis. And it has a domain, well, we can continue this on all the way through the whole negative side of the number line. So we can use any negative number, so we can approach negative infinity. So the domain goes from negative infinity to infinity. As we go to the right here, there's no limit to how big the number is, how big a number we can put in here to calculate it, although once we get up to 100, the result far exceeds the number of particles in the known universe, so the graph would be very, very high. The graph gets vertical very quickly, but it never gets vertical, almost vertical very quickly. And its domain, again, as we go to the right, we can use any x, so numbers again approach infinity as we go to the right along the x-axis, and the y values go to infinity much, much faster than the x values go to infinity. Okay? So there's the domain, there's the range of the complete basic function. And just a little blurb here. If we wanted to figure out 2 to the 1/2, the best way you might have to do it, if you don't have a calculator in your hand, is just to estimate where this is. Okay, well, halfway between 1 and 2 is about here, so it looks like that's maybe 1.3 or 1.4. So if we estimate 1.4, we're actually pretty close. It's a little more than 1.4. Okay, so without worrying about that, there's your summary.